Kia ora koutou. Here's question 2b from the 2018 paper after a very long gap. So this is a triangular question and it's got three parts to it. So let's quickly have a look at them, because the part that you might think is the excellence part is not really the excellence part. So it's a bit weird. So we're given this information and it follows on from 2a and it's all about a website. So the number of page views that the website received each day was recorded over 365 days. And we get this graph here. Right, so part one says that the owner's making a claim. The owner of the website states that the website got between 75 and 225 page views on 95% of the days. And we have to first of all show that the owner is wrong, and then show how that the range for that central 95% could be between 35 and 260 views. And we can do that by drawing on the graph. So I'm actually not going to draw much on the graph. I'm going to do it a different way. So it turns out that this is the excellence question, and this is the assessment schedule. So you can pause the video on this if you want to, but I'd suggest that you could actually watch the video instead. So here's the assessment schedule. And then 2b2 says, okay, let's suppose that we're going to fit a model to this, and we're going to use a triangular distribution, not surprisingly. And we have to give the parameters for a triangular distribution based on this thing here, right? So you can see we're going to chuck on a triangle, and it's going to look like this. So I might as well do this one right now. I'm going from the minimum value to the maximum value. You can see that each of these groups is 50 wide. So this one starts at 25, and this maximum one here goes up to 275. So I'm going to have A is 25, B is 275, and C is not 125, it's 150. So remember, what are parameters for our distributions? Well, parameters are kind of the fixed values that we need to find probabilities. So in a triangular problem, the parameters are this number, and this number, A, B, and C. The parameters for a normal distribution are mu and sigma, or sigma squared. The parameters for a binomial are n and p. And the parameters for a Poisson, well, there's only one, and it's lambda. For a uniform, the parameters are just the min and the max. So that's what parameters are. So there you go, we've done 2b2. That was an achieved question. The last bit, which when you read it, you might think this is the excellence part of the question, is actually not. You're not looking for that much here. So this is a merit part. We have to explain whether we need to use a continuity correction when we're figuring out an estimate for the probability that the website gets more than 150 page views tomorrow. And then we have to support our answer with calculations that compare the use and non-use of a continuity correction. But no, apparently that was merit. So let's go back to the first part and see how we can do that pretty thoroughly. Well, we've got our data, and the data is in the form of a histogram. So we need to look at what's going on in here. We've got these categories. So the first category goes from 25 to 75. The next category goes from, well, I guess 75 to 125, and then 125 to 175, and so on. Now, you can't have part of a page view, so we've double counted the 75 in here. So I guess really you could say that this goes from 25 to 74. And this is what the continuity correction question is getting at, that we've got discrete data here, even though we've drawn our graph as if it's continuous. But really, given that we're talking about quite a wide category, it's fine to me to go 25 to 74 without a gap. All right, it's not strictly correct, but it looks all right. So we want to show that the website owner is wrong, and he or she has claimed that 95% of the days have between 75 and 225 page views. So the first thing I'm going to do is I'm going to add these numbers up and check what they add up to. Now, they should add up to 365 days, but this is the level 3 probability paper, so maybe they have mucked it up. They only did that once. But happily here, these numbers do add up to 365. So the middle 95% of values 95% of 365 gives me about 347 days. So what I want to check is whether if I go between 75 and 225, I get that many days. So 75 to 225 days covers these three numbers. This one, 80, 125, and 85. So adding those up doesn't give me the right number. It only gives me 290 days. So 290 over 365 is equal to 79.5%, which is well below 95%. So the owner is wrong. So let's look at how we could figure out a good estimate of the central 95% range. So let's take all of this off. Well, if I want to have 347 days covered, then I need to be chopping off 9 days at each end. So 347 days means that we want roughly 18 days not included. And we might as well go symmetric and say 9 days at each end. So let's look at where we're going to chop those off. And this is where drawing on the graph is quite good. Well, we've got 45 days in here and we've got 30 days in here. So we want to chop off 9 at each end. So 45 days, 45 days had web page views between 25 and 75. So if we draw that out, we've got 25 here, we've got 75 here, and so 9 over 45 is 1/5. So if we go 1/5 of the way along here, so 1/5 of that distance gives me 10 days. And so we're going to add that on to 25. So 25 plus 10 days gives me 35 days for my lower bound or lower limit. Right, so remember what we're trying to do is to figure out where will 347 of those days come in this range. And at the other end, we've got 30 days in that top group. So top bracket goes from what? Well, it goes from 225 to 275. We can draw that as a bar. And it's got 30 days. We want to go 9 back. So 9 over 30 is equal to 3/10. So 3/10 of 50 is equal to 15. So we want to go 15 days back from 275. So 275 minus 15 gives me 260 days. So what have I assumed when I'm doing that? Well, I've assumed that the days are evenly spread in each category, right? Whoops, let's just try and erase all of this. So when I'm doing that, what we call linear interpolation, of placing the 9 days evenly in here and evenly in here, I'm assuming that the 30 days in there are not mostly clumped around here and around here. So I'm assuming even spread within the groups. And it's probably worth jotting that down, right? So this assumes days spread evenly in each group or class. Okay, so that's that one done. Now that took a long 9 minutes. Let's quickly look at the schedule for that one. Okay, so you can see that what you had to do is you had to show that the owner is wrong, and then you had to have, for merit, you had to have a good crack at trying to figure out the 95% values. So you had to have both of those things done for excellence, right? So I think that's actually quite it's just a bit of common sense reasoning, and you've just got to show how you thought about it. Right, we've done B part 2, which was looking at what the parameters are for a triangular. Now we're going to move on to B part 3. And here we have to explain whether we need to use a continuity correction. So I think the way that I would have said this is that, strictly speaking, we do need to use a CC, right? And the reason for that, we do need a CC because page views is a discrete random variable, right? It's a counting value. So it's a discrete RV or a discrete thing. But the triangular distribution is a continuous one. On the other hand, we're going to find out that it makes very, very little difference if we use that continuity correction. And the reason for that is that the numbers are pretty big relative to how I'm rounding. So going back to the graph, what we've got to do now is, where are we? Where's it gone? Oh, I've lost my graph. All right, graph's up here. We've got to find a probability of being over 150. So without a continuity correction, we're going to put our triangular doodah on. There it goes. We've got to find this area. Now, without a continuity correction, this is super easy because it's symmetric. So this number here is 25, this is 150, and this is 275. So by symmetry, this side is 125, and this side is 125. So the probability that without a continuity correction, that the page views is over 150 is simply going to be 1/2. You can do that using the formula, but you don't need to, right? Because of symmetry. So let's see what it would look like if we did do a continuity correction, and we're going to see that it's very, very close. So I'm just going to add in a clean sheet and get on with it. So we've got our lower bound down here of 25. We've got 150 here. That doesn't look symmetric, but there you go. The first thing I do is work out the peak height, which is f of 150, right? And that's 2 over the base, which is 250, and that gives me 0.008. I'm going fast because I'm assuming you've got good at triangular by this stage in the year. So if I'm doing a continuity correction, the probability that x is greater than 150 should be treated as the probability of finding x dash greater than 150.5, right? So I don't want to include the bar, the kind of bar in my head that's got exactly 150 page views. I want to start with the next one, which is 151. So that's why I do this. And when you work that through, we have to find the height at 150.5. So going back up here, doing our usual thing, there's 150.5. If you're doing it the similar triangle way, we've got 124.5 here out of 125. So we're going that fraction of the way up to the top. So f at 150.5 works out to be this. Which is very, very close to it, which is showing you that it really makes very little difference if I bother doing a continuity correction. So we get that, and then the probability is going to be half the base times the height, and that gives me 1/2 times 124.5 times that number there. This is appalling working, sorry, if any proper teachers are watching. I'm sure you'll leave me a comment. So we get that, and it's very close to 0.5. And the other thing going on in here is that all of our data is in categories anyway, right? So we go back to here, it's not like we had really, really accurate data to start with. We had quite rough grouped data. And so it's kind of like dancing on the head of a pin to go and do a continuity correction because we've got grouped stuff going on in here. And then we're going to go and do this really fiddly thing with the continuity correction. So I would argue that you don't need one, but I do that by showing that it makes very little difference. Okay, let me know if that helps. I've just about run out of time, so I'll do another question later on today.